Okay, so we'll do the proton NMR first. Okay, let's look at this. So you see we have a way of answering things and you have to follow the stuff. So I'm marking it in with a very, very stringent manner. All right. So please take the advice humbly. All right. Like here, the students actually make a good effort in writing. Hydrogen have their own spin, which is correct. All right. But it's called spin states. All right. So the spin aligning and against the external magnetic field, correct? Okay, causes them to split into two different spin states, which correspond to two different energy level. All right. So it depends on the examiner. If the examiner is not strict, you could have gotten full marks, but the proper way is to write like this: energy level and then spin states. Okay, don't use the terms interchangeably because these are scientific terms, these are not daily terms. Okay. Any questions? No, but generally you can see that the students have a clear idea of what is going on in the proton NMR. Just need to work a little bit of refining the phrases. Okay, then, so when methanol is examined using NMR, it absorbs at two different frequencies. Explain why and predict the relative areas of the two peaks. So I think this area is rather misleading. We don't know whether they are referring to as in the area under the peak, because that one actually means how many hydrogen you have. Or is it the area in terms of the chemical shift? All right. So I think I read the mark scheme sometimes before. They will accept both answers. So the best way to get the marks is actually to give both answers, right? Then read the question. This arises from the protons in the CH3 and the OH group. This is very good. So you attribute them to the CH3 and the OH group in different chemical environment. All right. You should have the word chemical environment. All right. So this is confirmed, 1 mark here. All right. Which give rise to different, or with okay, this one says it says give rise to the different frequency. No. Different chemical environment give rise to the absorption at different frequency. So if you want to write like that, you have to be very clear. All right. Then the two peaks is actually occurring at the value given should be in the correct range, respectively. Right? It will be even better if you can attribute this to the CH3 and this one is the OH, respectively. Right? So another point that I think worth noting is because they say relative area, right? When you have a peak, the area under the peak basically represents the number of hydrogen in that it belongs to. So in this case here, even without looking, we can sort of like predict it will be like this. You have a short peak and then you have a 3 times taller peak. So this is actually the CH3 and this is the OH. So the area under the peak ratio is 3:1. Okay, but basically the students already score enough point for 2 marks. Okay, this is just one additional piece of information. And who knows, right? Maybe one day they decided that, hey, let's give the students the 3 marks. Then it is actually the peaks area. Are we good? Yeah. So again, peaks area could mean two things. It could be, it could mean area under the peak or the peak height, right? Or it could mean the chemical shift of the peak, right? These students, I mean, not this student, this question is definitely not specific at all. All good? Yeah. Okay, then you have C3H6O2. So, and it has 2 peaks. So this is correct. I think it's no problem. Explain which compound produced the spectrum as shown. So we look at the compound. It has 2 peaks at 2 and also 3.5 respectively. 2 and 3.5. So definitely cannot be propanoid, because propanoid will have 3 chemical environment. Okay, methyl methanoate have 2 chemical environment. Something is missing. Huh? There is another hydrogen here. Good. Yeah. See, one missing hydrogen. So this thing, everything correct is actually 1 mark. So because of missing 1 hydrogen, you score 0. 0 out of 1. Yes, because this is already A level, right? So you are supposed to know how to write chemical structure for all of them. So this one is also 3 chemical environment. Okay, so this correct. This is correct. It is methyl methanoate. Okay, usually in the analytical chem questions, the marks is given for why is it A, and also at the same time, why is it not B? Okay, so you should say it's methyl methanoate because it has 2 peak, while the other 2 ester actually have 3 peaks. Okay, because it has 2 peak and the other has 3 peak. So please paraphrase your answer. Hello, everyone understand? Yeah. Okay, next, the NMR of another compound has a peak at 11. 11 is propanoid lah, so this is no problem. Then down there is X-ray crystallography. Which atom cannot be detected? That will be hydrogen atom. Okay, but you don't want to answer also, never mind. Right, now let's look at the next question. So last time, before 2016, there is a lot of biological question one, ATP lah, and all that. So it is no longer that. So you don't have to worry about it. Okay, now explain with reference to energy states how HNMR can give information about the structure. So this is a descriptive question. So let's see how the student is answering. I mean, it's optional to give diagram now, I think. Wait, Oh, yeah, it's optional. They just give you space just in case. Okay, the different energy states of the proton arise due to their different chemical environment. Right, so this is 1 mark. Very good. Okay. Different chemical environment correspond to different molecular structure. This is redundant. This is the same as the previous one. So maybe you can give 1 mark lah. Then analyzing the chemical shift value can give an idea about the chemical environment. Okay, all right. But you need to go down to the basic. Like you need to explain why are they actually absorbing the energy at different frequency. So the student is actually missing, the background information. So what do you need to write? You still need to say that when you have a proton, all right, it will be split into 2 different energy level. Why? Because this one is opposing the external magnetic field. This one is aligned with the external magnetic field. All right, I think 3 marks means you have to start from the root cause. And indeed, this is actually the root cause. Right, so you have to explain to them this one. Okay, the magnetic field is very, very crucial. And also the energy gap is actually very, very crucial. Right, so if I mark, I won't give full, probably 2 out of 3 or even 1 out of 3. Did you mention frequency? Yes, but you didn't explain why where the frequency comes from. So the standard answer is you talk about the spin state that is actually separated into 2 right? One is the one that is opposing, one is the one that is actually aligning with the external magnetic field. Then talk about this producing a energy gap between the spin state. Okay, then you talk about that it can actually absorb at a certain frequency. Okay, so these are the crucial information. Okay, don't leave them out. You can write extra, but you should never write less. Okay. Okay, NMR is used in NMR, blah, blah, blah. Why MNR is better than X-ray? Then you say it's not damaging. Okay, and also not blocked by the hard tissue like wood. I'm not very good in biology. Is that a real thing? Is it called a hard tissue? I don't know. But definitely will not get blocked by the boots. Okay. Then you have the MMR. So I presume you are correct. 4 carbon and then 8 hydrogen. Okay, you see, this is why I'm very worried when I look at the student answer. I think I explained before, right? You have to give sufficient argument. This one, even though the structure is correct, is only 1 mark, you know. So including this should be in the answer space. The student will score a max of 3 out of 5. That is less than enough, you know. So the proper way to do it, the 5 marks, the final structure is only 1 mark. I know the student managed to get the final structure correct. Congratulations. But you have to use it to work it out. Understand? So you have to tell people what are your working. So definitely calculating the number of carbon is 1. Calculating the total number of hydrogen is 1. Okay. Then you should also describe and assign the peak. So don't leave out the assigning peak. Like here in this case, we can see that there is a peak at the CH3 and then you have a CH2. Oh, sorry, terbalik. This is the CH3 peak. Yeah, this is the CH2 peak, and that is the CH3 peak. Then probably you have another CH3 that is not adjacent to these two. So you have to explain to people what are the peaks attributed for. Okay, so the student's structure is actually correct, you know, CH2, CH3. Okay, and then this is the CH3 that is actually alone. So you should write description explaining how you come to the conclusion. Right? And then you should use the keyword that you have been taught. This is high resolution NMR. So you should tell them peak at chemical shift equals to 1.2 is a CH3 adjacent to a CH2. Why? Because it is a triplet. Meaning itself is a CH3 next to a CH2. All right, or adjacent to a CH2. Then at peak 4.0, at chemical shift equals to 4.0, okay, it is actually a CH2. Why? Because it is actually a quadruplet adjacent to a CH3. Adjacent to a CH3. Yeah, correct. You have to talk about who they are and who is their neighbor. Understand? Yeah. Okay. Then this CH2 is also attached to an O. That's why it is actually shifted so high. Okay. So it should be dash O dash CH2 here. Right? you have to say that it is a quadruplet. You have to say that it is adjacent to a CH3. And when the marks is given, it is given for complete description, right? That means if you don't say the triplet and you don't say who it is next to, you could have ended up losing marks, right? So you give this description, you get score 5 already. Okay, but of course we don't do that lah. We finish up the question, then we explain to them at the chemical shift equals to 2 ppm. It is basically the O and then dash CH3. Okay, that's why it is actually shifted slightly higher. All right, and it is actually a singlet because no hydrogen on. No, you cannot say no hydrogen and adjacent carbon. It doesn't even have an adjacent carbon. So you can just say it with the singlet, and that. Yeah. Okay. Then the final structure is correct. So you see, it's actually not so much of a matter of the answer. The student, if the student can deduce correct structure, means the student understand what I just explained. But you have to show the examiner what you know. Okay, otherwise, again, you are not going to get full marks. Okay, next question. I think I count this. Yeah, that's why I take. Because if this is wrong, then everything else would be wrong. Okay, so it's 5 carbon. C5H10O2 plus. Okay, the mass spectrum has a peak at ME 57. All right, then you have to figure out what it is. So 57 maximum carbon is 3. So this is 36 plus 5 plus 16. Yeah, correct. This is actually 57. Need to put a plus sign here. Why? Because they are actually not atom or molecule. All right. Oh, really? Okay, that's weird. Okay, so after you minus out the C3H5O, then you get C2H5O. So this is correct. But it's missing the positive sign. All right, only positively charged cation will be showing up as a peak, right? So the use of TMS and CDCl3, I think this one I explained many times already. Reference, this is solvent. So this is 3 marks. Then this is the proton NMR, right? By considering the relative peak area and also their values, right? Deduce who they are at 2.2. Okay. This 2 is definitely right next to each other. CH3, CH2, this is correct. Then you have CH3, CH2. Then you have 2 singlet. Oh, interesting. 2 singlet. That means they are separated somewhere. All right, so this is correct. CH3 at 2.2. And then this is a CH2 right next to an O because it's shifted very far. Okay. So when reacted with aqueous alkaline, all right, it produces a yellow precipitate. Then this is actually correct because CH3CO is what the 3-iodomethane test will be reacting. Okay, but this is wrong. This part is wrong because you see, CH2, CH2, CH3, what does that mean? That means it's actually not separated, so it is not congruent with your peak. Okay. So this one is actually the CH3C double O. Okay, but you cannot have two CH2 right next to each other. Because if you have CH2 and CH2 right next to each other, this particular peak have 5 adjacent hydrogen. Then it will not be a quartet. It will become a multiplet. It will have 6 peaks like this. Okay, it will be a sextet or a multiplet. But on our graph, we do not see a multiplet. So this is not possible. Can? Hello. So I don't know. Okay, so we have a CH3. This one we know. Then we have a C double O. Okay, then we have how many hydrogen in total? C5, right? And then we have the previous information here. We know that we have a C3H5O. You see, this question is a continuous question. C3H5O is like this. This is a C3H5O. Oh, wait, no. This is a C2H5O. Oh, sorry. This one. Okay. So this is the C2H5O. So putting this piece of information together, then we draw another one, macam ni, CH2, CH3, right? So it's not O CH2, CH2, CH3. It is O CH2, CH3 only. Okay, so that's why at the first look, we know that this one is actually wrong. Are we good? Can, right, so we need one more carbon that is in the middle. C double O. We put one more carbon in the middle. And this is a CH2 that is separated. It's just like this. This is the correct structure. Okay, then if we assign the peak, it totally makes sense, right? This is, let's say I name it, this is carbon A, B, C, D, E. Sorry, not carbon, hydrogen. All right, hydrogen. Okay, so this is the carbon A. This is hydrogen in carbon A. This is hydrogen in carbon B. This is the one that is right next to a C double O and an O. So this is actually the C, and this is actually the D. So the correct structure is like this. Are we okay?
Sure.
Yeah.
The previous page, right, the splitting of the C5H10 one, that one we have to refer to the next page, only we can know how to split. Or do they accept multiple answers?
This one.
Yeah, the number 2.
What other split you have?
C4H9.
What?
C4H9. Then
C4H9.
another CO.
Oh, also 57. Cannot, because doesn't agree with here. Correct?
So have to refer to the next page one now.
Yes, have to refer. I mean, if you go to the next page, you will have realized something is not right. Because if you have a C4H9, surely you have a lot of multiplet one. Okay? Both carbon number 2 and carbon number 3 will get multiplet. Because this is CH3, CH2, CH2, right? So carbon A and carbon B is going to end up getting multiplet, right? So does it make sense? Can?
Okay.
Any other questions about this? Yeah, still got blah blah blah. Oh, this is NMR with a peak of 9 to 1. Ah, hey, Ying, this is the one. Can? Cause got 9 to 1. Hey, wait. No. This is wrong. You see, it has only 2 peaks. Okay, if it has only 2 peaks and has a 9 to 1, it's macam ni. CH3, 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 and then C. Okay? Because if this is a structure, you have 1, 2, 3, 4, 5 peaks. No, they show you that it only has 2 peaks. So this one is very, very wrong. All right, so it should be like this. Then you have a 1 here, and then all this 9 is actually in the same chemical environment. All right. Can 1, 2. Yeah, correct.
Yes.
It's okay. Don't worry. This is only set A. Haha, got set B one. So you need to do, okay? And I really hope you enjoy doing it lah. Okay, but of course only me will do that. Okay, so compound B is a carboxylic acid which contains a chiral center. It also has the chemical formula. This one is macam-macam way lah. As long as you got a chiral, it will do. COOH, CH3, C2H5, and so H. Okay, this is no problem, I think. Right, next. Instrumental analysis, blah, blah, blah. But both techniques, I think we did this together, right? I don't know. Did we? Okay, never mind. So both technique use part of the electronic spectrum. Actually, we can use the entire electronic spectrum. IR, last time the one you learned in AS also can be used. And in this case, we use X-ray, and then NMR is actually in the radio wave frequency. Okay, so all sorts of spectrum could be used. Okay, so which technique use radiation with the longer wavelength and in which part of the spectrum is found? Right. So they actually suggested NMR and X-ray crystallography. I know X-ray is not in, but they can still phrase a question like this, because X-ray obviously is the one with the shorter wavelength. So NMR is the answer, and it is actually using the radio wave region. Okay, you still remember red monkey in very ugly X-ray glasses. Right. Radio wave is the proton NMR. H and C NMR actually. All right. Infrared is the one that you used last time. All right. This one is also very good for organic chem. Visible is the one that we use in analysis of the transition metals because they have different color, right? Okay, actually visible to ultraviolet. And X-ray is usually used to analyze what we call the crystalline structure. This one is not popular in, oh wait, I can't say that, all right? This one is not listed in the syllabus anymore, but it's basically the technique that people use to discover the double helix DNA structure. Okay. NMR provide detailed information about proton, but X-ray is unable to detect them. So explain these effects. Actually, you can still answer this in the perspective of the NMR. All right, you can talk about the proton having the different spin states. Right? Then talk about the align and also oppose with magnetic field. Talk about creating an energy gap. Then talk about the absorption at different frequency. Okay, and then talk about how this is actually affected by the chemical environment. Actually, still can answer. Okay. Now, this one no need. Okay, but just so you know, it is sulfur, right? Because it has the highest electron density. Okay. I didn't check this, correct? Because if this is wrong, then all the further analysis is actually C3. No other information. In spectrum P, clearly indicate the peak due to OH group. Yeah, 4.6, right? State how many chemical environment is present in compound Q. So 3 peaks, 3 chemical environment. What evidence is there in this spectra that P is primary rather than secondary alcohol, right? So if it's a primary, it will have 1, 2, 3, 3. Wait. Yeah. Secondary will only have 3 chemical environments. Yeah. Okay lah, acceptable lah. Let me see the marks. 1, 2, 3. Oh, is everything correct? 4. Then it will be insufficient. Insufficient point. Okay, I think the student has a misconception in his head. Right? This is 1 mark. Understand? Then you have to look at it. How many ticks have I put so far? This is part D, right? Counting number of carbon is definitely going to be only 1 mark, nothing more than that. So 1, 2, 3, 4, 5. So score is 5 out of 6. You're missing the point, probably because you did not count. And also the student doesn't have the mentality that you have to give detailed explanations, sufficient points. Okay, so to score 5 out of 6, you need to give enough information. This may be correct. I think this is correct because 1, 2, 3, 3 chemical environment. Yeah, so this is actually correct. Then this is a CH3, CH2 couple. Then, so yeah, so it has to be a COOH. Then this one shifted so high, so must be a COOH peak. But what evidence is there in the spectra that P is a primary rather than secondary alcohol? So if it is a primary alcohol, it will have 4 chemical environment. Okay, you have to give explanation like this. Can? Then you might want to also analyze the split pattern. You see, this is a very typical multiplet situation. In fact, you can see that the students is actually trying to analyze the situation over here. But I'm not sure whether it's correct or not. This is definitely the OH peak, right? Then you have 1, 2, 3. This is the OH peak. 1, 2, 3, 4, 5. It should be like this, with a double bond somewhere in the middle, right? So what do you have? You have a 2, 3 peak. 2, 3 peak means the carbon in the middle actually have 1 hydrogen only. This is the triplet. This is also a triplet, right? Meaning they are actually adjacent to a carbon that has 2 hydrogen. Sorry, it should be like this. Can? Yeah, and then this one is a multiplet. So if we zoom in and we count, we got 1, 2, 3, 4, 5, 6. 6 means the neighboring carbon has 5 adjacent hydrogen. All right, so 1, 2, 3, 4, 6. So it's like this, no? Yeah. Okay. So let me clean it up. So this one is carbon A. Carbon A. This is carbon A peak. This is carbon B. This is a hydrogen on carbon P peak, because it has 5 adjacent hydrogen. All right, so 5 adjacent hydrogen. Then this is actually carbon C. Then hydrogen on carbon C, and then this one is the OH itself. Right? So carbon A and carbon C both are triplet. Why? Because there is actually the adjacent carbon has 2 hydrogen. This is actually a point that you should write down there so that you can get marks. Okay? Okay, huh? Right. Or you can say that they're adjacent to a CH2, right? So so we have to write like this. At chemical shift equals to 1 and also 3.5. They are both triplet, meaning the adjacent carbon has 2 hydrogen. So just write this point, you can get an additional. So don't leave it. Okay, huh? I think it's a matter of answering technique. You will be very dumbfounded. Oh, 5 marks. You have to count the points one. Oh, sorry, in this case it's 6. Right? So if it's insufficient, then you have to goreng something that is appropriate. Means not make up something. You have to write extra points to get it. Okay. This one I counted, so it should be correct. Oh. Then you have 1, 2, 3, 4, 5, 6. So again, 6. Actually, we don't call it a sextet, right? Even pentet also don't have. It's basically just called a multiplet. But you have to zoom in and count a little bit. Blah, blah, blah. Okay. Use this information and your answer to deduce. Oh, sorry, I didn't read this properly. So I assume this is correct. 4. I think so. C4H10O, because it has a ME value of 74. So 48 plus 10 plus 16. 48 plus 10 plus 16 is 74. And then you see they give you 3 marks, right? So what do you have to do? You actually have to give a calculation. Otherwise, it would be insufficient points. So work out something. Just show them what is the molecular formula of T. So yeah, if C4H10, because the relative molecular formula of C4H10O is equals to, show the calculation now, right? It's equals to 74. Just to get that extra working marks. All right, again, count the points. Be careful. All right. So the NMR spectrum of T gives the following absorption peak. All right, and then you have 2.5 is a singlet, and then you have 2 duplet, right? So this is wrong. Why? Doesn't give rise to the structure. What? You have 2 duplet, you know. What is duplet? Duplet means the adjacent carbon actually only have 1 oxygen, 1 hydrogen. So how can this be correct, right? And if you think it's C4H9O, then you just draw the structure lah. Yes, you have an alcohol somewhere, right? And then you have a duplet. Duplet means the CH and the CH is actually right next to each other. Understand? Okay. Then after that, you have a multiplet, meaning you have a carbon that is in the middle and it is actually surrounded by a lot of hydrogen. Okay. So put all the informations together. Hey, why so many marks is given on 3? Oh yeah, the explanation in the back, right? So the deduction, okay, we start from the deduction, otherwise cannot work out the structure. Okay, pick at 2.5 is caused by OH group. Okay, singlet caused by OH group. Pick at 1.8 is caused by C. Okay, the rest of the argument is not appropriate already. Okay, don't start with a structure in your mind. Okay, I don't know how the student figure out the answer, but if your answer is not in agreeable with the structure, then it is not acceptable. Okay, or I think I teach you how to sketch the sketch the NMR peak based on the structure, right? You see, this one, carbon A, B, C, D, and then this is the hydroxyl. Okay. Carbon A, neighboring got 2 hydrogen. This will become a triplet. Carbon C and B, they are both multiplet. Carbon D is actually going to become a triplet. All right, then this one is a singlet. So if this structure is correct, what would the answer be? The answer, the spectrum will actually be 1 with 2 triplets and 2 multiplets, which is not the case. Understand? Okay, so we are very familiar with C4H10O, right? It's basically a hydroxyl. And then if worst come to worst, you can actually list out the possible structure. Why you need to do so? Because you see, if your structure is wrong, then all these arguments are wrong one, you know. Okay, maybe I can still salvage 1 mark for you for mentioning the OH group. Okay, so the adsorption is 1.8 is a multiplet. Both the adsorptions are duplet. Duplet. D-U-P-L-E-T. This is due to the CH2 and CH3 group having adjacent. Okay, see? No, because you're deducing based on a wrong structure. This will dissolve because of the T2O absorptions. This is correct. This is no problem. Okay, so you are losing, this is 2 marks. So 2, 3. So you're scoring 3 out of 9, which is terrible. No, don't do that. Okay, worst come to worst, do this. You draw the possible isomers for the C4H9. So you can have like this, OH in the middle, right? Then you count 1, 2, 3, 4, 4 peak. This will be a CH3, CH2, CH, and then CH3. Okay. Hey, wait. Then this one will be a duplex. Okay, because neighboring carbon only has 1 hydrogen. This one neighboring carbon actually have 3 hydrogens, so this will be a quartet. Then this one neighboring has 2 hydrogen, this will be a triplet. So already wrong. Can? Then we rule this out already. Then we find other isomers. Wait, so 1, 2, 3, 1, CH, CH, CH3, CH3. All right. Oh, this one cannot. This one is the one that will only give you 2 pick. So definitely out already. Okay, find another one. 1, 2, 3. Okay, so we can actually deduce from the formula. Okay, you have 2 duplex. Okay, so this is actually 1 duplex, another also duplex. No, the carbon, the hydroxyl is actually at the side. 1, 2, 3. Hydroxyl is at the side. This one. Yeah, found it. Yeah, this is the one. Kind of makes sense. Okay, so this is the correct structure. This is the singlet. All right, this one here, the neighboring carbon, the neighboring carbon only have 1 hydrogen. So this is the duplet. Right. This one, oh no, cannot. We're so lazy. Should have done it earlier, right? Yeah. OH. This is correct. Neighboring carbon, 1 hydrogen. So we got duplex here, and then another duplex here. Carbon here. Yes. So this carbon here is the multiplet, right? Then you have singlet. 1, 2, 3, 4. 1, 2, 3, 4. Yes, this is correct. Oh, finally. Okay. Yeah, this is one group of the duplet, right? This is another group of the duplet. So this one is the multiplet, right? And then this one is the hydroxyl. Okay. Then you write argument according to the structure. Okay, and even without deducing the correct structure, you can also write argument. No worry one. Okay, like in this case, you can tell them chemical shift A equals to 2.5 is a singlet due to OH. All right, chemical shift equals to, I don't know, 1.7 is a duplet, right? Then you can tell them adjacent carbon has 1 hydrogen. Okay, chemical shift equals to 3.3 is a duplet. Adjacent carbon has 1 hydrogen. Okay. From the peak itself, right, describing the shape and also the adjacent carbon and all that will be sufficient already. Okay. All right, and then chemical shift equals to 3.3. Oh, sorry, this is not 1 point. This is 0.9. Okay, or 0.8. Then chemical shift at 1.7 is a multiplet. Okay, yeah. So write the argument, even though you don't know how the structure looks like. Then only you figure out a way to describe this. I mean, figure out a way to put the informations together, right? So that you can get the structure correct. All good? Can, huh? And in C4H9OH, you list out all the possible isomer, sure one will get, right? So let me see what marks I can get. Right, you see, these students do not describe the split pattern. Please remember to describe the split pattern. A lot of marks is actually given to the split pattern. Right? I think that the students have no intention to describe the split pattern at all. So cannot. Part 3, duplet. Oh wait, this is actually correct. Yeah, sorry, you get 1 more mark here. Okay, if both the adsorptions are duplet, this is because, okay, you don't be specific lah. This is because they are having, okay, this is because the adjacent carbon atoms have 1 hydrogen attached. Okay, so that's how you should write it. Okay, adjacent carbon has 1 hydrogen atom. Because you say this is due to the CH2 and the CH3, you could be wrong. Okay, so very dangerous. Okay, but this one is actually correct. Hello, are we good? Then we count. And explain the split pattern. Duplet is 1 mark. So 1 mark and then the explanation is so 2. So this is 2. Structure itself is actually 1 mark. Why my screen is like that? You need to keep pinching here and there. Okay, so 1. Oh, then you have to write a lot of arguments over here. Okay, so this is insufficient. Are we good? Yeah. Anyone got correct? This one? Check. Patient, did you do this paper?
No, I forgot about it. I did the carbon one instead.
Yeah. You correct this question.
I think I got the structure. I think I got the structure correct, but I didn't write the next ones.
Ah, why? Now you know what to write, okay? Now okay, as usual, harvest as much point as possible. Okay, one spin, this is same thing. Okay, number of hydrogen 9+1+2, which is very faint. D2O, right? The peak disappear. 0.9 is 3CH3 group. What does the adsorption tells you about the adjacent carbon atoms? What groups are responsible for the absorption at 0.9? 3-methyl group. Okay, because it's a 9, isn't it? If it's a 9, then it has to be a 3-methyl group, not just a methyl group. State the structure of P. You cannot. Right? You see, P got 3 peaks, meaning it has 3 chemical environments for the hydrogen. Right? It has 5 carbon atoms. So if it has 5 carbon atoms per molecule, and then it has 3 chemical environment like this, right? So it means you have a 3-methyl state like this. This one is 2 peak. All the carbon, all the hydrogen are actually in the same chemical environment. All right. So in this case, what will happen is you will have only 1 peak. So after you draw the structure already, you have to try to match your structure with the peak. Understand? If it doesn't match, that means something is wrong with your answers. Clear? Huh? Okay. So the structure is deduced based on 5 carbon. Okay, so we finish up here. Okay, so you see, none of them has split pattern one, you know. No split, right? No split means there is no hydrogen on the adjacent carbon. Okay? Okay. All right. So, and then there is actually an OH group. So one of the peak is due to OH group. Which one? The one with only 1 hydrogen. No? This one is due to OH groups. 2 means it is basically CH2, like this. So you have a CH2, all right, in the middle, and then after that, you have an OH group. This is the structure. How do I know? You see, in this case here, all these 3 hydrogen, hydrogen on all these 3 carbon are actually having the same chemical environment. And then the adjacent carbon, which is carbon A, this one, have no hydrogen. This is why they appear to be all singlet. Right? And then this hydroxyl is always singlet on its own. Okay, then you look at this. This is the CH2. The CH2, the adjacent carbon also have no hydrogen attached. Okay, so that's why everyone is singlet in this particular spectrum. Okay, so this is actually the structure of P. How do we deduce? Based on 2 things. You don't just focus on the chemical shift. That is very wrong. You also have to focus on what? You also have to focus on the split pattern. All right. So this one is wrong. But it's only 1 mark lah, so I guess you are lucky lah. Right? What does the adsorption at 0.9 tells you about the adjacent carbon atom? So the answer is, it is a singlet, isn't it? So you mentioned that. If it is a singlet, it tells us that adjacent carbon atoms has no hydrogen. That's what it is telling you. Okay, and again, you have to understand what is meant by adjacent carbon. It is the carbon right next to it. So if you go back and look at the structure, the 0.9 are this one, right? Okay. So you look at the adjacent carbon. This is the adjacent carbon. This adjacent carbon is all attached to C1. It doesn't attach to any hydrogen. That's why they all appear as a singlet. All right? Yeah. Okay. Right. When an isomer of P is heated with concentrated sulfuric acid, it forms a new compound Q. Yeah, this one is A-level chem now. Right? So you have an ethanol, heat strongly with concentrated sulfuric acid, you do a hydration. So P is ethanol, hydrated to Q, so Q must be alkene, right? Which is proven by the next statement. This new compound Q reacts with bromine to give a dibromide. So they already told you it is a dibromide. So reactant with Br2, you get Q, and then after that, Br2. Then calculate the number of carbon atoms. I think this is correct. Predict the ratio, 1 to 1, also correct. Okay, so C5H10Br2, cause 2 bromine. Okay, don't leave this one blank. You know it is 5 carbon, all right? Then after that, you also know that it is having 2 hydrogen. So it is a 5 carbon alkene reacting with 2 bromine. So that's why we know it is C5H10Br2. That's how it works. Okay? Yeah. Don't means what? Already did, right? So,
Yeah, done means we did it in class.
oh, we did it in class. How many carbon?
Let me check. Teacher, I can't find the.
Okay, now never mind, we count on the spot. 100 times 3.35 over 1.1 times 3.3.
7.
7. Confirm?
Yeah, I found the working.
Okay, good. So explain what element is indicated by the M plus 2 peak. So this is a 3 to 1 ratio, so must be a chlorine. Okay. So explain. Oh, so you have to tell them the M plus 2 peak ratio is 3 to 1. Therefore, only you conclude it must be a chlorine because they have the keyword here is actually explain. Right? Then you have a 4 to 1. 4 plus 2 plus 1 is 7 protons and 3 chemical environments. Oh, you put a star.
I wasn't 100% sure.
Oh, okay. And now you know whose paper it is. But never mind, yeah, you have been together since O level already. Okay, it's okay. No need to be shy. Some students very thin skin one, you know. I mean, I'm very thick skin. Like, I don't get embarrassed. It's not positive thing. When you are studying, it is a very positive thing. Ask lah. No dumb question. Only those that's not asked. Okay. Use the information given to deduce the structure of L. Explain how you achieve your answer. So this one I deduced already, right? Done, yeah. Okay. Then we move on to C3H6 presence in two-way, blah, blah, blah. One difference in the fragmentation. This one got a CH3. All right. This one, no matter how you fragment, also will be CH2 or actually it could fragments like this. You can fragment like this and like this. So this one you will get a CH2 and a C2H4 peak. This one also have CH2, right? So this one cannot be, it's not acceptable. You have to look for the differences. Both also can have CH2 fragment, right? So you're actually stating the similarities. You should state the difference. So you should state that propene can have a CH3 fragment, but cyclopropane cannot. Okay, state the difference. Okay, CH2 is quite contrary the similarities, right? So not a very good pick lah. I mean, not a very good answer. Okay, suggest two differences in the NMR. Then you count the chemical environment. No? Cyclopropane will have higher peak of chemical shift range than propene. Propane will have a peak for alkene chemical shift. Yes, that's correct. And cyclopropane wouldn't. All right, you have to state the range. Okay. And let me see. Okay, it's total 3 marks, right? So this one is 1 mark. Then you need another differences. Oh, the student is attempting to talk about two lah. Higher peak for alkane chemical shift. Taller, right? I think you mean. Yeah, but when you come to proton NMR, you should, the one very important thing that you should always acknowledge is the number of peak. This is very important. Okay, because sometimes based on number of peaks alone, we can deduce the structure already. So you should state number of peak rather than where to find them. Okay, so you can just tell them if you have a cyclopropane, as you can see, all the hydrogen is identical, you will only have 1 peak. Okay, but for a propane, you can actually have 3 peaks. This is one very important point. Okay, then the statement that you make, the statement that the student make is all talking about where to find them. That is actually another point. Are we good? Yeah. 1, 2, 3. Yeah, 3 peaks. Any questions? Yeah. So number of peak or number of chemical environment is very, very crucial. Please include it in your arguments. Wow, 3 o'clock already. Okay, then we have to do faster. Oh, this one I haven't talked about. I think it's correct. 3. I guess no one would make mistakes, right? Oh, all done, huh? Okay, then we skip this question. Eh? No context one. M plus 1, 3. Then you have ME73. Also, it's just a guess lah. Okay, so 3 times 12 plus 14 plus 16 is equals to 73. Y is equals to 7. Oh, so it's hydrogen. Yes, okay, then use the information explaining how you arrive at your answer. Ryan, what is the problem? Shouldn't raise my voice, but dude, how many marks you want?
4.
4. How many marks will you be getting?
2.
2. Okay, I don't know whether your structure is correct, but you are definitely not getting full marks. You need to get marks for the explanation. Understand? Okay. So in this case here, use the data from together to deduce a structure. Explain how you arrive at your answer, totally ignoring the explanation. So if we zoom close enough and see, we have a quartet right next to a triplet. That means you have the CH3 and a CH2 structure right next to each other. So this structure is wrong already. Right? This is a triplet. This is actually a quartet. Okay, so triplet and quartet right next to each other basically means you have what? You have a CH2, CH3 in your structure. So you can write about this. Understand? So how to write? You have to tell them chemical shift at 1.0 is a triplet. So that means the adjacent carbon has 2 hydrogen. Chemical shift at 2.2 is a quartet. That means the adjacent carbon has 3 hydrogen. So from this, we can deduce, all right, chemical shift at 1.0 is a CH3, then this one is actually a CH2. Can, then you get 1 mark and 1 mark for the deduction, right? Even without knowing how it looks like. Then we look at the formula. C, C, I got N and O one. Oh yeah, it's a very rare question. This one has N and O. So you have a CH2, CH3. Okay, so I want you to memorize. This one is not remember already. No time to think. So actually we need to memorize. What do we need to memorize? We need to memorize that, all right? There will be a CH3, CH2 structure if you have a quartet and a triplet right next to each other. Okay. So then you have COO and H2. 1, 2, 3. 3 carbon, right? Yeah, 3 carbon. That's it. Apa lagi? No other way already, right? Yeah. Okay. Then why the structure is wrong? You see, this structure, these 3 hydrogen and these 3 hydrogen, they are going to be singlet one, you know, because the neighboring carbon doesn't carry any hydrogen. In fact, this particular hydrogen here, there is not even a neighboring carbon. So it's very, very wrong. Understand? Yeah. Then this bump here is actually due to NH2. Okay, you can write about it. Yeah. So you can say one more point. Then the peak at, I don't know, it's 6.3 is due to NH2. See, so many points that you can write. Hello, all good, huh? Let's move on. Skip. Oh, okay. I remember this question. Okay, this is those questions that need a lot of description now. All right, so you actually can get a lot of marks one. So number 1, you score correctly for number of carbon, very good. All right, then number 2, you score correctly for y equals to 4 plus 3 plus 1 equals to 8, number of hydrogen, very good. Structure, don't write first. You will never know the structure. Write the argument here because down there you're supposed to predict the structure. All right. Then you have a 3, 4, 1. Okay. So you have to deduce the almost 1-to-1 ratio means there is a benzene ring. Very good. Okay. Then the pig tells that there are 4 hydrogen attached to the ring. Benzene ring, not ring. Okay. 5.5 tells you that there is a hydrogen in a phenol group. Okay, very good. Then 3.75 shows you that there are 3 hydrogen attached to a carbon as a methyl group. Very good. But the structure is wrong. Because if you do this, this 1, 2, 3, 4 hydrogen, they are not going to be symmetrical. But never mind, I think they will give you marks. Right? I think this is the better answer. You have an OH, you have a CH3, then it's a 4-methoxy phenol. Yeah, this one is actually more appropriate. Okay, why? Because you see the 4 hydrogen are actually relatively the same, but this is air level, so actually you can get correct. No worries. Are you? Okay. Oh, finished. Like, my goodness, finally. Okay, not very good. So need to do another set, Uncle.
Yes, teacher.
I need to do before next week. We're free now, right? Supposedly. I don't know. Okay, let's look at the carbon NMR. Oh, start from the top. Oh, I think this one I explained already, right? I remember talking about retention time. Time taken for compound to travel through the column to the detector. Yeah, correct. Okay, presuming that this is correct. Actually, I don't know one. Okay, use the data booklet. 3 marks, you know. Only 1 point. For chemical environment. Yes, correct. Pick at 210 is what? Don't know. 3 marks. So you need other points. You tell them these are all LQ. All right. The 2110 is don't know what. Wait, Okay. It's actually a matter of experience so cannot blame you. Right? You need to use all the information given. Okay. So here they tell you that the ME peak is 86. Okay. So you have a C5. H don't know what, O don't know what. Correct? Okay. Then if you have 5 carbon, 86 minus 5 carbon is minus 60. You got 16. Right? So 5 carbon, 5C. 1, 2, 3, 5. Hey, 26. My goodness. I was wondering why so little. Like not enough to put an oxygen. So the number of oxygen you can have is equals to 1. Because if you've got 2, that would be 32 already. So your molecules is actually not big enough. So we agak here. This one is 1. Hydrogen, don't know also, never mind. They're not very important one. Then you deduce they are not even asking you to deduce the structure. They're asking you to guess. So we should know that this peak at 2110 ppm is actually due to C double bond O. You can refer to the data booklet one. Then this group of peaks that is between 10 to, I don't know, what is this, 45? These are the LQ group. LQ are the peaks at the range of 10 to 45 ppm. Okay, data booklet can help you with all this. Please refer to the data booklet. Wrong also never mind. At least you write something rather than leaving it blank. Okay, so attitude is very important. And you know what? It's actually trial and error. You see, sometimes I also will get stuck and then I will need more time to do. And think here, think there, then eventually you will figure out something. All right. You cannot memorize answer one because how many molecules? Who knows what they're going to give you, right? So you need to cultivate the sense of adventure when you're doing this. Okay, so you write like this, you can get 3 marks. Just write lah, let the examiner be amused. Okay, amuse me, please. No other answers. Oh yeah, then why is one of the 3 isomeric ketone, R, S, and T? Okay, so you have to tell them which one it is. Which one it is? How many pigs? 4 pigs. So 4 chemical environment. So 1, 2, 3, 4. 1. Oh, this one is symmetrical. 2, 3. So not S. 1, 2, 3, 4, 5. 5 chemical environment. So must be T, lor. Yeah, that's how you get it done. All right. Okay. No more. Okay, this one is skip. Oh, I think I marked already. Oh, I think it's correct. Maybe I wanted to skip it only. I don't know. State a reagent for this reaction. So what is this? COOH turn into COCl. So it is the ethanoid turning into ethanol chloride. Okay, so must be using SOCl2 can, right? PCl5 also can, up to you lah. Right, then you have the chemical reaction as such, CH3OH, so you have a double ester, then you have an amine, then you form a double amine, okay, a cyclic amine, which is really cool. Oh, this one I did, right? I remember doing this.
Yeah, you did already.
Yeah, I did, yeah, so I skip. Oh, this one don't do, okay, because this is what the enzyme, the lock and key model, so it's removed from the syllabus already. I think this is a very old question. Yeah, quite old, not very old. But this one you can do. Okay, so basically they are just asking you to deduce the peak. Then I think I told you before, okay, the closer you are to something that is electron negative, then the higher the chemical shift. Right? So you have phenyl ethanoate and methyl benzoate. Oh, it's isomer. Yeah, they're isomeric to each other. So you can refer to the data booklet, then you can deduce what is all the peak all about. So LQ group is usually very low. Yeah, this LQ group is shifted higher. Okay. Then 169. Methyl benzoate is isomer A. Yeah, just look at the LQ group will do. Okay, correct. And this must be B lah, right? So you have phenyl ethanoate and methyl benzoate. All right. So they are actually kind of like both also ester, but you see it has this particular structure. You should recognize CH3CO, right? So if you have CH3CO, then you can actually do the aqueous alkaline thing, right? So they are difficult to distinguish chemically. Describe a method of converting them to a suitable product in step 1 that can be tested in step 2. Oh yeah. So you have to convert first, then after that you test. Okay, so we have phenyl ethanoate and methyl benzoate. You can do hydrolysis lah, right? So when you do hydrolysis, you cut here. And then this one, you cut here. So this will turn into a benzoic acid. Right? Then this one will turn into a phenol. Then you just have to mention a test for the phenol or mention a test for the benzoic acid. Are we good? Yeah. They are ester, so we hydrolyze them. Okay, so you can tell them you're just going to add HCl aqueous, then you heat a little bit to hydrolyze, not hydrolyze lah, to do hydrolysis to the ester linkage. Okay, then phenylethanoate. Phenylethanoate tells you the alcohol, all right, will produce phenol. Then you give a test for the phenol. Are we good? Yeah. Then the methyl benzoate, on the other hand, will hydrolyze to form a benzoic acid. Then you give a test. Oh, benzoic acid actually no test one. Okay, never mind. Then we do the phenol one. Okay. Yeah. Right. So it's not that hard. If you don't want to do step one, then you can straight away just use aqueous iodine. But in this case, cannot, because they want step one convert and only you test it in step two. All right. Don't leave it blank. Phenol. Oh yeah, this is a good question. So the name of the drugs used in medicines often include parts of the name. And so you have chloro, ni, and then OL. Okay, so chloro tells you that it has chloro. Okay, then AM tells you that it has amine. Amino also can. Phen tells you that it has phenol. So crazy, right? I know, right? Oh no, not necessarily phenol. Can be phenyl, can be a benzene ring. So phenyl. Okay. What else do you have? Then OL tells you that it contains alcohol. Wow, so crazy, man. Yeah, cool. Okay, so any of the two lah. Suggest two functional groups. So anyone. State the role of ketamine in this case. So it is actually acting as a base. AY is circle. Should be correct. Okay, because you can see clearly it is actually accepting a proton. Then ketamine gives an orange precipitate. So it has a carbonyl. That's very good. Use the number to show that 13. So presuming you are correct. In addition to the carbon and hydrogen atoms, each contains one of the three elements that are heteroatoms, and one of them is actually a halogen. Use figure in the table to suggest why it is halogen. So M and M plus 2 is 3 to 1, so it is actually the chlorine halogen. This is good. Then no attempts already. Then no good. Another peak in the mass spectrum has an ME value of 240. Predict the relative abundance of 240. Why 240? 240. Oh, okay. Yeah. So 14.3, 100 to 33.3, right? MM plus 2, right? So it is a 3 to 1 ratio. So 14.3 divided by 3. .7 something around there now. Okay, use this information to complete the molecular formula of ketamine by working out the identities of 3 different heteroatoms and the number of hydrogen present. I know, so mafan, right? Okay. Actually, it's just a guess. So you got C13, H don't know how many, and then confirm you have a chlorine. All right. And then the name got amine, right? M, right? M means it also contains nitrogen. And then got the alcohol, right? So that means it also contains oxygen. List it out first. All right, don't leave it blank. Okay. Then what else do we know? We know from here, we use this one, we use 237. Okay. The Me is equals to 237. That means the RMM of the molecule is equals to 237. Then we minus, right? So 13 times 12 is equals to 156. Minus 237 is equals to 81. Then minus, this is minus 12, 13 carbon. Then we'll minus 1 chlorine, because you know got chlorine already, okay? And you don't have a M plus 2, M plus 4 peak. That means only 1 chlorine is present. So because we are using the lowest peak, okay? So minus 85 plus 86 is 46. 46. So we try to minus 1 nitrogen, 14, 32. Minus 1 oxygen, minus 16 is 16. I think cannot already. That means you cannot have 2 nitrogen or 2 oxygen. Why? Because if you have 2 nitrogen and 2 oxygen, then you don't have enough hydrogen. And carbon 13 is very long. So basically the answer is C13NO and then got Cl, right? So we have 16 left, right? That means you have 16 hydrogen. And they give you 1 mark, you know. But this is how it is done now. It's like, doing maths on it. Okay? Yeah. All right. So actually we should do this. Okay. I thought they would do
Actually,
what?
I don't really get why is it 14.3 times for the number 5. I'm not really sure how to do the.
You see, this is M. This peak, the M is actually when you have a carbon 12, and then after that combined with a chlorine 35. And yeah, carbon M plus 1 is when you have a carbon 12 and a chlorine 30. Carbon 13 and a chlorine 35. So this is a carbon 12 with a chlorine 37. The M plus 2. That's how we deduce the ratio, right? So when we say M plus 2, that means the ratio is 3:1, isn't it? And then here, if they have a value of 240, is here, right? So 240 means you have a carbon 13 plus a chlorine 35. Get it?
Oh,
so the peak ratio, if this is 14.3, this one must be 14.3 divided by 3. Then it is just equals to 4.7. Okay? 4.8 actually. Hello, are you right?
Oh, okay. So it's carbon 13 with chlorine 37, right?
Oh, sorry, yeah. Carbon 13 with a chlorine 37. That's all. Actually, I don't quite get it. What is patient do? Oh, sorry. I shouldn't mention name, but I'm a noob. It's correct, oh? I think it makes sense lah. You know, this is basically just divide by 3. This is a 3-to-1 ratio. 1-to-3 ratio. Yeah. Straight away divide by 3. Okay. Okay. Wait, a good thing got a substitution question one. Very much. Oh yeah, got. Okay, and then you have what? Ayyo, I hate this. Then whatever. Okay, suggest a pick in the carbon 13 NMR. This one sure got a lot. What's this? Oh, it's actually symmetrical. So 1, 2, 3, 4, 5, 6. Okay, so 6 type. Wait, let me double check. This one show different 1, 2. This 2 is same because it's symmetrical. 3, 4, 5. These all 4 carbons are actually the same. Yeah, so 6 pick. Right? Then you have to assign the pick. Oh, this is proton NMR. This is a new question, you see. Very much 2019, they started to introduce carbon NMR. Then the question will mix proton NMR and carbon NMR together. Right? So pick at 0.9. You get 12. Right? And they are all singlet because the neighboring carbon has no hydrogen. Pick at 1.3, got 1 is a singlet also. Okay, makes sense. Yeah, actually it's all singlet. Yeah, they are all singlet. Because it's all separated. Okay, the neighboring carbon is actually all separated. So you can see, I mean, you look at the structure lah. Okay, you see this carbon here, neighboring carbon of full 1. So it's all singlet. Okay, complete the table. Why you circle? You're not confident of your answer, but it's actually correct. Yeah. Oh, then assign them. 0.9, yes, correct. 1.4, very far away from the nitrogen. Okay. 1.7, this one is the highest shift, so 2.2. Okay. NH2 peak disappear, replaced by D to form D2O. No, cannot write like that. Which one? NH2 plus D2O give you NHD plus HOD. Or the hydrogen in the amine can actually all get replaced. Then you get ND2 plus H2O. All right, so it is the hydrogen from the amine, write properly, and H2 is replaced by D. But to form D2O is wrong already. It's not to form D2O, it's replaced by the D from the D2O to form something else, to form HOD actually. So I don't know, maybe the student is not thinking straight when he or she is doing it. Okay. Yeah. Okay, to dibromol. B. Oh, addition carbon. Okay, very good. Nitro. Okay, CN hot under gas with. This is easy. And direct cannot be oxidized by this ethane diode can. Okay, set the project. Oh, ethane diode. Oh my god. Such a yeah, this one is old question. Give acidity. Skip. Because I want to finish this. COOH 3H. Okay, all right. What am I saying correct for? Of course, it's correct, like it's given, right? Okay, then 3.3 is actually it's a triplet, so it is a CH. Then this one is actually the CH3. Okay, good. It's a quartet, means the neighboring carbon has 3 hydrogen. Butan diode. Butan diode is very symmetrical one. So 1, 2, 2 peaks, correct. Methyl propane diode. Methyl propane diode. Sorry, need to think a bit. So 1, 2. Oh, many. Circle the wrong one. 1, 2, 3. Okay, 3 peaks. Also correct. Oh, control. Actually, I don't know what is this. Okay. Oh, I'm not already. 0, 2, 1. Yeah, I counted. Because very 麻烦 you need to count. So 1, 2, 3. 1, 2, 3. This is the secondary, got 2. All right, this one is tertiary, got 1. Yeah. Give the number of chiral carbon atoms in one molecule of acetyl. Okay, I don't want to do this. Sorry, really easy to count. But I guess it's correct lah. Okay. Is geometrical isomerism? Then again, you have to count. So I'm going to skip this also. Predict the number of peaks in the carbon 13 NMR spectrum of X. So this one is kind of symmetrical. So you got 1, 2, 3, 4. So 4 peaks because you have 4 chemical environments. Okay. What? Yeah, you have, what do they want? Okay, you have the one that is attached to the COO, and then you have the one that is the CH2 in between. So yes, this is correct. Okay, but I presume you check lah. Okay, yeah, this is correct. 3 peaks and peak each. Okay, predict the number of peaks that could show up in the proton NMR spectrum. Oh, I only got 1. Okay, so this is a H2 and they are identical. So on a peak. Oh, very good. For each of the peak, it must be a singlet because there is no adjacent carbon, no hydrogen attached to the adjacent carbon. Very good. Then 2 carbon containing products. All right, when you oxidize this kind of thing, you ended up getting what we call a carbon dioxide. All right, following by complete oxidation. Of these two carbon-containing products, identify the product with the larger molecular mass by drawing its structure, right? So you take this and then you just split it, and then you get the molecular structure. Should be fine. So you oxidize already, right? So you got a ketone over here. Then this is gone, this is gone. And then this one will be closing up. Wait. 1, 2, 3. Yeah, correct. Just closing up. Just draw this part. Okay. I think we are done. Yeah, no more. But it's quite a rough patch, I would say, but not very good. So you need to do another one. You still have time. I'm not sure if I sent you before, but I just want to send now. This is actually not the latest lah, the newer set, I would say. Okay, so we do some together. Oh my God, wait, let me close my window. What's this like? Whoa, let me admire the wind. Goodness me, it's like crazy. And then a few weeks ago, the place where I stay, got a hailstorm. So cool. It's not cool at all. Okay, it's kind of like those apocalypse situation, right? Like the world is going to end. That's what it is. Yeah. Okay, just give me a moment. Yeah, talk about tree uprooting. In my area, the tree uprooted so much until it is really like those zombie movie, we cannot go out to buy food. That's how dangerous it is. Okay? Because my area only got one exit for the car. And then at that particular exit, one of the big tree fallen. Yeah, so scary. Wait, I cannot find my phone. Just give me a short 2 minutes. 去哪里了？ HNMR set B. Let's see. This one is also you also have to do lah, no choice. Was very bad. Okay, let's look at HNMR set B. This is still not the latest. I got another one that is the latest, but I seriously don't know where I put it already. See, it's not here. Okay, I might do this one first. Okay, on top of that, I want to check. I will call name lah. So year 2022, February, March, October, May, June, and also October, November. The paper 4. Ryan, have you done all?
No.
None, nothing. GG. Okay, not even one set. Are you saving it for something?
No, I think I've done it before, but a longer time ago. Like when I was preparing for mocks.
Including the ON, the October, November one?
Oh no, I think I only did May, June, and some of February, March.
Okay. So, patient?
I did a few variants of February, March, and May, June.
Ying
I didn't do because I want to save for real exam. So
Okay, yeah. I'm about to tell you the same thing also lah. So we don't do first. We save the October, November for a little bit later. Can? Can. Right. That is after, not too late also lah. I think next week you can do. Right. If you really want to do now, it's also fine by me. Okay. But you pass maybe one set to me because I want to mark so that I know what is going on. So maybe let's say we do just one set for one. Can? Yeah. For one as your homework. Silence is consent. Yeah. Now look at this. Let's do this one now. So very clear. It's the October 2022 paper 4-1. One set only. Get it done by, I don't know. Can you give me earlier? Mid of the week? Because I need time to mark one, you know. Okay. So I think by Thursday or before Friday. Yeah, before Friday lah. Then at least I get one day to mark. Can? Okay. All right, let's look at this. You do. Okay, I'm just going to sit here and do nothing. Okay, so that's how fast you should do it now. Like is 7 marks, so you roughly next about like what 7 minutes. Okay, so read the question. They tell you that you have an alcohol Y and oxidized to turn into a Z. Okay, so the number of hydrogen that the proton NMR is actually shown. So you see, the first spectra actually shows you there is 3 chemical environment. The second spectra shows you that there is only 1 chemical environment. So this one must be the alcohol, cannot be the product of the oxidation. Okay, we don't know what Z is, but you know what? When Z is formed, it actually has only 1 chemical environment. So what could that be? When alcohol is being oxidized, it can either form aldehyde. So Z could be aldehyde, but aldehyde is like this, it has 1 hydrogen and then the rest is others. So it cannot be aldehyde. Okay, then how about if it undergo further oxidation? Lucky cannot be carboxylic acid, because carboxylic acid also have an OH group. Okay, so there cannot be 1 peak one, must be at least 2 peak. Understand? Right? So spectrum number 2 is actually the product of the oxidation. Okay, spectrum number 1 is the hydroxyl, because if you have an alcohol, it will at least have 1 hydroxyl peak, and then 1 is the hydrogen coming from the other carbon. Okay, so this actually suggests to us that state which spectrum is produced by hydrogen must be spectrum number 1. Give a reason, because spectrum number 1 has more than 1 peak. Alcohol, no matter how small the alcohol is, even when you have methanol also, there will be minimum 2 chemical environment for the hydrogen, like this. So spectrum 1 has more than 1 peak, right? So one of the peak is for OH. Okay. So alcohol would definitely have more than 1 chemical environment. So alcohol cannot have 1 peak. So you can argue this, or you can give a counter argument that, okay, this is actually because spectrum 2 only 1 peak. Alcohol will have more than 1 peak. Either way also can. Okay, then count the number of carbon. I think this one everyone can do. Right, then deduce the structure. Right, so to deduce the structure, we have to give sufficient points. Okay, then we have to come back and look at it. Right, there is 3 carbon, 3 carbon. Right, And we already rule out the possibility of aldehyde, cannot be aldehyde, because aldehyde would definitely have more than one peak. Cannot be carboxylic acid also, because carboxylic acid definitely has more than one peak. So it can only be ketone. And it is a ketone with 3 carbon. So the only possible answer is a propanone. So this is how we can deduce why it is propanone so quickly. Can? Yeah. So you have to write all this explanation, and now I'm scattering it all over here. But if you look at the marks, the mark for part B is actually 7, right? Then you see structure is 1 mark, counting number of carbon is 1 mark, then identifying the spectrum is 1 mark. All right. Why the MNR only shows 1 peak is 1 mark? So 1, 2, 3, 4, right? That means you need to give 3 statements that explain how you come to your conclusion. This is what you have to do when you're answering the question. You answer whatever that is very specific first, then you count how many score is needed. Okay, so now we know that, oh, confirm we got 4 already, 4 marks already. Then we give 3 statements that explain how we achieve our conclusions. All right, so this is a little bit of working backwards. But in real life, when you do science, when you do engineering, this is basically, I mean, no marks will be given up, but you will be trained to give a very complete answers. Okay, that's scientific thinking. All right. Yeah.
The multiplet at 4.0, right? Is it the OH hydrogen?
No.
Then the
OH hydrogen. OH is singlet one, ma. So must be this one.
even though it's an OH hydrogen, it's not further down the absorption range.
What is the range for OH? Can you check the data booklet or the notes or whatsoever?
0.5 to 6.0.
Yeah, so it's in the range. OH is always a singlet. Can?
So the singular CH will have more absorption at higher ppm than the OH.
Oh, you're talking about this one, right? Yeah, it's actually a bit high because it's a C next to an O, right? So is it still in the range? What is the CH range?
3.2 to 4.0.
Yeah, it's in the range one. Actually, I also don't really check the range one, as long as other information is sufficient. Okay. And all right, so we have to now explain in detail how we work it out. And then we need to make sure we have at least 3 points. A. Okay, so we can tell them, okay, spectrum 2 is a ketone. Okay, because oxidation of Y could produce aldehyde and carboxylic acid, but they have 2 peaks at least, more or equals to 2 peaks, right? Only ketones will have 1 peak. All right, then you just tell them C is actually ZH3, CO, CH3. This one will give you 1 mark 1. Okay, so if you know Z already, then you can deduce. Therefore, Y is actually CH3, COH, CH3, CHOH, CH3. I don't have space already, lah. You know, you draw the structure. Okay. Which is a secondary alcohol. Okay, so this is how we deduce. And then after that, if you are still not sure, you can start assigning the pick one, no problem one. Okay, so what do we have? We have a duplet, right? So you can tell them the chemical shift at about 1.1 ppm is a duplet. Okay, that means you actually have a CH3 next to a carbon or adjacent carbon has 1 hydrogen. So you can deduce like this already. Okay. And chemical shift at 2.0 is the OH group. Why? Because it is actually a singlet. Then you can also deduce chemical shift at 4.0 is multiplet. So it must be the CH, okay? And then the adjacent carbon has 6 hydrogen in this case. Actually, it's not really clear how many subsets there are or subpicks there. All right? So this is definitely more than 3 arguments. Okay, there is no easy way. I have been doing this for 16 years, still make mistakes. So you have to do. DNA also never mind. This page can just skip. Right? No longer in the syllabus. You focus on the proton NMR. You do the paper 41, and then I will send you another copy. Yes, that is the carbon NMR. Because this one is all proton NMR only. This is proton NMR set B. Right? Then there will be a carbon NMR set B. Okay? Can I? All right. Okay, I think that's it. Any questions? What do you do every day? Study lah. Do what? Okay, study 16 hours every day. That's what I did when I was doing my STPM. You can do it too. All right, all the best. See you next week. Bye-bye.
So Wednesday got class.
I think no need,
Are we having any more Wednesday extra classes?
no need. Because we finished the syllabus already. Is there any particular request, like a certain topic that you need help in? All right, then no need. We'll do the regular Saturday. Okay.
Okay.
Okay. Bye-bye.
Thank you, Joe. Bye.
Thank you, Joe.